Welcome to U.S. Preparatory's Radio Communications for the Prepper video series. This chapter is dedicated to Storford repeaters. The purpose of the following video tutorials is to help preppers and the like be more aware and educated in radio communications, the options that exist, and to assist the average individual to develop a relatively inexpensive, far-reaching communication system with little to no experience in radio communications. This tutorial is to generalize certain aspects of the presented material without going into every possible detail, variable, or viewpoint about any given subject. Although there are what some might consider techie parts of the presentation, it is necessary to explain some of the finer details of the content and to help clarify the point. The viewer should keep in mind that the concepts and functionality of the presented material is the focus here, not the technical side of the systems or setup installations. The information within this video series are based on actual experience in both commercial public safety and amateur radio and may not always follow popular opinions. The series of videos have been made to enlighten, inspire, and inform the non-radio folk and help make the subject of personal radio communications more about independent, self-controlled systems rather than a community-based system that you have little control over. Until this point, we have presented video chapters covering radio terms, frequency band characteristics and selection, portable radio mode types, and XTR extender systems. Now, we'll explain how to expand your system to a wider area using a Storford repeater system. Combining all or some of the concepts and techniques learned in the previous chapters will give the prepper or individual a reliable, professional caliber communication system for far less cost and technical knowledge than thought possible. The Storford repeater portion of the presentation will consist of the following chapters. The Storford repeater system's basic of operations. Comparing Storford repeater systems to other forms of radio communication. Choosing your Storford repeater configuration. Advanced configurations and features. Expanding your Storford repeater system. And Storford repeater best practices. The financial resources of commercial two-way radio and government allows for the no-compromise communication systems. The massive financial resources of these entities means that they have the best, purchasing the highest towers on the highest elevated land with the best equipment, best paid technicians to install, configure, and maintain the system. They can afford not to be all that efficient because they have the money to make up for this. Preppers, on the other hand, are not generating income from their communication system, nor do they have the massive funds available to them. So the choices that are made in creating a communication system is critical. Making the right choice of equipment, frequency band selection, and placement of the equipment is crucial to a successful system. Our intention is to simplify and clarify this process by explaining the options, methods, and equipment, but also to guide you in your selection of frequencies that best suit a particular need. This is presented within this video series and reflected in the Preparatory Emergency Groups or PEG radio licensing program designed specifically for the individual or group communications needs. Store and forward repeaters are also known by other names. Simplexer, Parrot repeater, Echo repeater, Simplex repeater, and Storford repeater. The term Storford is a combination of words store and forward. This term has been adopted as the name of choice due to the other terms being misleading and a source of confusion between other terms and the repeater's mode of operation. For example, a Storford repeater can be used in both simplex mode but also half-duplex mode, therefore the term simplex repeater isn't accurate for this tutorial. Discussing simplex, direct radio-to-radio communications without the use of a repeater, and the simplex repeat function of the Storford repeater will likely be very unclear and confusing to a person not familiar with radio communication and its various modes and methods of use. Generally, Storford repeater controllers offer the same features: voicemail capable, small size for portable use, DTMF remote control capable, relatively low cost of ownership, a range of voltage inputs to power the system, at least 30 seconds of high quality record time, Vox signal detection to sense an incoming signal, and low power consumption for prolonged use when on battery power. However, there are a few critical features that are missing from nearly all Storford repeater controllers: Features necessary in order to configure one of the enhanced Storford repeater systems shown in this tutorial series. Transmit audio delay adjustments. COS signal detection replaces Vox detection method. Q-tone busy indication system with preset hang time. Adjustable Q-tone duration and frequency. RNC compatibility for use with multi-zone Category 3 systems. U.S. Preparatory has passed the requirements along to Argent Data Systems to produce the first enhanced Storford repeater system master controller, the SMC100. This controller has been specifically designed for the enhanced Storford repeater system shown in this video presentation. A Storford repeater system actually consists of two devices, a Storford repeater controller and a transceiver. The controller is the heart of the system, controlling all functions including sensing an incoming signal, recording the signal, switching the transmitter on and repeating the audio is just some of the basic functions provided by the controller. The transceiver allows all the radio traffic on frequency to be received and transmitted per instructions from the controller. The controller and transceiver make up the Storford repeater system. The basics behind a Storford repeater system is very simple. The Storford repeater receives and digitally records radio traffic activity on its frequency. Once the message is complete, it immediately repeats or retransmits this traffic to receiving field radios. This simple concept, although not real-time, offers some very significant advantages over real-time systems, many of which are not obvious but extremely important to low-budget communication systems. Comparing Storford repeater system to other forms of radio communications. The vast majority of radio communications in use today is typically not critically time-sensitive. The exceptions being public safety services, military, and extreme emergency uses. Storford repeaters, when configured properly, offer a very cost-effective means of providing an inexpensive, highly adaptable radio platform with features that simply don't exist in other forms of radio communication systems. There are many unique traits to a Storford repeater system, some obvious and some overlooked. Many are assets to a user or group. Some may be less than ideal. Pointing out and explaining each of these characteristics and later enhancing the good and minimizing the less desirable traits is the focus of this part of the presentation. It should help the individual, prepper, or group to better understand the benefits of such a system and compare these concepts to other more popular forms of radio communication. A standard duplex repeater requires two sides to make it function: a receiver to allow it to listen to field units, and a transmitter to push the message out to monitoring field units. These two elements are separate but operate simultaneously. A precisely tuned duplexer is responsible for the simultaneous interaction between the transmitter and the receiver. A duplexer requires an experienced level of understanding and very expensive, specialized equipment to precisely tune the frequency pair being used. If a change in frequency is necessary, the duplexer must be retuned. A typical duplexer can be fragile, susceptible to damage from small impacts, preventing its ability to perform correctly, and can be very susceptible to temperature fluctuation, causing the tuning to drift. This can be a problem in off-grid installations where climate control isn't available. Keep in mind that the duplexer is transmitting and receiving at the same time using the same antenna for both. This is no easy feat. The transmitter output power and the offset between the transmit and receive frequencies have a significant impact on the achievable isolation from the duplexer. All duplexers have a minimum rated frequency split that they can perform it. Without this crucial isolation, a condition known as desense will occur. Desense can occur and is fairly common with low-budget duplex repeaters if adequate isolation isn't achieved and maintained between the transmitter and the receiver. The condition essentially allows the transmitter to interfere with the receiver. Since the transmitting and receiving is occurring simultaneously, the receiver is fighting to listen to the field traffic due to the transmitter desensitizing the receiver. Initially, the first 25 to 200 milliseconds, the repeater receives the field units normally without desense. However, the moment the transmitter begins to transmit, the desense occurs at the mix point of the duplexer. The end result is strong signals are severely weakened, and weak signals are not received at all. essentially a repeater that talks better than it listens. The transmitter signal itself is unaffected, but the repeater can only repeat what it receives. Bad audio in is bad audio out. A desense condition essentially makes a repeater near deaf, resulting in a far less usable service area. This receiver desense condition simply can't exist in a Storford repeater system due to the basics of its operating characteristics. Field radio desense can happen when two in-band portable radios are within close proximity of one another. Remember that the radios are receiving each other from the standard duplex repeater, not directly, so it's possible that the receiving portable radio doesn't receive the transmitting portable radio at all due to the transmitting radio overwhelming the receiver of the receiving radio. This receiver desense condition doesn't exist in a Storford repeater due to the basics of its operating characteristics.
Coming northwest 5. Chance of rain 50%. Saturday, partly sunny. Highs in the lower 60s. North winds 5 to 10 miles an hour. Saturday night, partly cloudy. Lows in the mid-40s. Northwest.
It can be confusing why users can see one another but not be able to communicate with them. This can be dangerous in a public safety situation such as a building search when two officers are in the same building on a portable radio. If this form of desense occurs, the communications between the two officers will be compromised or perhaps non-existent. Most radio equipment is rated in percentage of duty cycle. Duty cycle is the ratio of transmit time to actual time. A 20% duty cycle radio is designed to transmit at full power for no more than 20 seconds out of 100 seconds. A public safety duplex repeater for police, fire, and other high-priority radio systems is typically rated at 100% duty cycle. 100% duty cycle equals transmitting 24 hours a day, 7 days a week, 365 days a year, forever. This rating requires a very expensive, heavy, and large commercial quality transmitter. This extreme rating ensures the equipment doesn't fail under prolonged usage during an emergency or in routine high-traffic conditions. A mobile base or portable radio only transmits when the user needs to send a message, otherwise it's in receive or standby mode. A repeater, on the other hand, is the link to all traffic. In other words, the repeater must transmit when any and all field radios transmit. Even if the repeater wasn't made for 100% duty cycle applications, it can still be subjected to high-demand situations simply by moderate traffic conditions. A standard repeater, regardless of the type, will transmit everything that it receives, even if it means self-destructing unless measures are in place to avoid catastrophic failure. A typical mobile radio is rated at 10 to 20% duty cycle at its rated power level. This portable repeater system is rated at intermittent duty, not designed for primary channels traffic requirements. Typically, the power level of the transmitting radio is reduced by less than half the rated power, and a high-volume fan keeps things at a reasonable temperature. Powered by a 120-volt power supply, these repeaters contain a notch-type mobile duplexer. This repeater typically weighs between 30 and 60 pounds, costs between $350 to $850 used, and requires the same technical experience and expensive test equipment to tune and configure the duplexes as any standard duplex repeater. A Storford repeater, on the other hand, is capable of only operating at less than 50% duty cycle regardless of the radio traffic, and is the only repeater system in standby mode more than transmit if the user's reply time is factored in. For every second of transmit time, the system must have experienced the same time in receive or standby time. This has a major impact in reducing the workload on the transceiver when compared to its duplex repeater counterpart. It's for this reason why standard mobile transceivers can be used for primary Storford repeater systems. This demonstration of a Storford repeater and a 2-minute message exchange between two portable radios. With no activity, the Storford repeater's transceiver is at rest. Upon radio A's transmitting a message, you'll notice that the Storford repeater transceiver remains at rest as it receives this message from radio A. Upon the completion of radio A's message, the system transceiver retransmits the message. At the end of this message, radio B is beginning to reply. A few seconds may pass before the field radio begins to reply. However, as radio B replies, the Storford repeater's transceiver is again in standby or rest mode as it receives the message from field radio B. Once the message is complete, the Storford repeater begins to transmit this message. The transmit time is equal to the length of the previous message. This goes on with each exchange between radio A and radio B. Notice how the transmitter on the Storford repeater is at rest equal to or more than in transmit mode. This is due to the natural operating characteristics of the Storford repeater. The same 2-minute message exchange between two portable radios, but this time using a standard duplex intermittent duty repeater. With no activity, the duplex repeater is at rest. Radio A transmits a message. You'll notice as the repeater receives the message, it simultaneously transmits, relaying the message out to radio B. Upon the completion of radio A's message, the system remains in transmit mode for the 3-second hang time to which radio B replies with its message. Again, as radio B transmits the message, the duplex repeater remains in transmit mode. This condition will remain for the duration of this message exchange between radio A and radio B until finally the conversation is complete. Notice how the transmitter of the duplex repeater is actually transmitting more than the activity level. Even with the adjustments to eliminate the so-called hang time, this type of repeater adds a tremendous demand on the transmitting radio. Combined with the expense and technical requirements to configure, maintain, and operate this system make a duplex repeater not a practical choice for individuals or a prepper group's radio system. Replacing the duplex repeater with a Storford repeater offers some immediate benefits to the system. It eliminates the potential receiver descents caused by the system's own transmitter because the condition is simply not possible in a Storford repeater, as a single transceiver replaces the separate transmitter and receiver. This is not unlike a mobile or vehicle-mounted transceiver. Since the transmitting and receiving is separate, a duplexer isn't necessary. This of course eliminates the cost of the duplexer and all associated support equipment, and the possibility of receiver descents, but that's not all. There's far less insertion loss. Insertion loss is the signal loss associated with any equipment placed within the path between the radio and the antenna. Expect a 5 to 15% gain in system efficiency with a Storford repeater when compared to a low-budget duplex repeater. This slide shows a working Storford repeater as it functions in normal operation. A field radio transmits a 10-second message which is received by the Storford repeater and digitally stored within the controller. When the field radio stops transmitting, the repeater retransmits the message. It's this characteristic that allows a Storford repeater to be so uniquely beneficial to a prepper when building a radio communication system. An obvious benefit to a Storford repeater when compared to a real-time communication system is that the transmitting radio will receive itself. This feature offers confirmation to the user that the message was decipherable to others. It also gives the user a way of self-testing the coverage of a system without the assistance from others. A Storford repeater is the only system that returns radio traffic back to its source. It's common knowledge to two-way radio users when transmitting on a base or a mobile two-way radio that a user doesn't hear their own voice coming out of the radio's speaker. This is because the radio is transmitting. As mentioned prior, most two-way radios are asynchronous. This means the radio can transmit and receive, but not simultaneously. Since the radio is transmitting when the user presses the PTT button, it can't receive. Therefore, the user's voice can't be heard from the radio speaker. This concept remains when an XTR or extended transceiver repeater system is connected to the base or mobile radio. The UHF portable radio works as a remote control to the base or vehicle radio it's connected to. Therefore, transmitting on the portable radio causes the base or vehicle radio to transmit as well. Since the base or vehicle radio is transmitting, it can't receive, making it impossible to hear the portable radio user's message directly from the base or vehicle radio speaker. The Storford repeater system augments these rules a bit and allows this impossible feat to become possible. The following slides show the contrast between a standard repeater system compared to a Storford repeater system when used with an XTR extender system. This is an example of a prepper group out at a local campground using 3 UHF portable radios and a vehicle equipped with an XTR extender system. Although all portable radio traffic is received and relayed to the main low-band repeater, each portable radio within the same group must be within range of each other in order to communicate. A group portable radio transmits. The vehicle XTR extender system and the group portable radios receive the message simultaneously as the repeater forwards the message to other field radios on the main system. Notice how each portable radio within the group must communicate directly. The XTR extender system, being asynchronous, is merely forwarding the portable traffic to the main system, not assisting the group portable radios to communicate. This is a similar example of the prepper group out at the local campground using the same UHF portable radios and a vehicle-equipped XTR extender system. This time, however, the Duplex main repeater is replaced with a Storford repeater. This is one of the many overlooked advantages to a Storford repeater system. A group portable radio transmits. The vehicle XTR extender system receives the message while simultaneously forwarding it to the Storford repeater. When the message is complete, the Storford repeater repeats it to all field radios, including the XTR extender system in the vehicle. The Storford repeater returns the message back to its source. All of the portable radios in the same group receive all traffic from the vehicle's XTR extender system. An XTR extender-equipped base station with a standard duplex repeater at its core. The portable radio won't be heard at all by the base radio. Transmitting on the portable radio triggers the XTR-equipped base radio to also transmit, resulting in the base radio forwarding the portable user's message to the repeater. Since a duplex repeater is unable to return the message to its source, there is no communication between the XTR UHF portable and the base it's connected to. The same XTR UHF portable radio and base station, with a Storford repeater at the system's core, allows the base station operator to receive the portable radio's user's message from the repeated audio of the repeater, despite the fact that the base station is actually part of the XTR transceiver system. With the Storford repeater at the core of this system, this typically impossible path of communications becomes possible. The following slides show another significant advantage of the Storford repeater being used in place of a standard duplex repeater, this time a graphical layout of a multi-zone wide area coverage network. The difference in cost savings, the less is more concept of achieving more functionality with much less equipment and far less technical systems, resulting in an expandable and scalable system that a prepper group can afford and service. But first, we'll see the conventional, traditional way of building multi-zone radio systems. We will then show you one of our favorite system layouts known as a half-duplex hybrid and transform all of its faults and shortcomings with a simple, inexpensive, and scalable solution known as a Category 3 PEG radio system. When a wider range of coverage is needed in a radio system, a single zone won't be enough. Typically, most amateur radio systems are expanded by adding repeaters to the area of each new zone and linking each repeater together using a link or a remote base port. The link port is an additional connection point on the repeater controller that allows a link transceiver to communicate with other repeaters in the network. For the sake of space savings in the next few slides, we have compacted the images of the main components. There are several components that make up a traditional single or multi-zone system. A brief explanation will help with the understanding of each component and its role it plays in a radio system. This standalone duplex repeater system is used as a primary repeater in a single-zone system, or as a link hub of a multi-zone system. As with any duplex repeater, it consists of expensive components that require special skills and equipment to properly install and use. Each of these systems consists of the following components: main band antenna, main band receiver, main band transmitter, repeater controller, and a duplexer. Standard duplex repeater with link transceiver. Main receiver activity forwards on the link transceiver, and the link transceiver activity transmits locally with the repeater's transmitter. This system is used in 2 or more zone configuration and tends to be the most common use of a standard repeater with link capabilities for amateur radio and commercial radio systems. It's also one of the most expensive and technically demanding. Each of these systems consists of the following components: a main band antenna, a link band antenna, link band transceiver, main band receiver, main band transmitter, repeater controller, and a duplexer. Note that the duplexer shown in the previous and following slides is actually a UHF model used for its small size to demonstrate the equipment of a typical repeater system. Most of the main band systems shown in these demonstrations would be in VHF low band frequency range. Therefore, the smaller 20-inch by 14-inch 25-pound UHF duplexer would actually need to be replaced with a rare low-band duplexer. Low-band duplexes are much larger, ranging from 6 to 9 feet in height and weighing between 130 and 190 pounds. Fortunately, the Preparatory Emergency Group's radio system contains no duplex components, eliminating the need for a duplexer of any type. A common method to link 2 zones is to use 2 link port-equipped repeaters. A field radio in Zone 1 transmits a message which is received by the zone's repeater. The repeater transmits the message locally as the link transceiver forwards it to Zone 2. This will cause the Zone 2 repeater to retransmit the message locally. The term local repeat essentially means that the field radios residing in the same zone communicate through the zone's infrastructure rather than directly. This is a major benefit in any multi-zone radio system, but with a high price in both cost and technical sophistication, as both of these zones contain a complete duplex repeater. One option to link more than 2 zones is to incorporate a link repeater which acts as a hub. All zone repeaters use their link transceivers to transmit and receive traffic between zones. Each zone offers local repeat. Since the system contains a link hub repeater and a complete duplex repeater at each zone, it can be very expensive, technical to install, and far beyond the cost most preppers will be willing to spend. As an attempt to eliminate as much duplex hardware as possible, a configuration known as split site is the configuration of choice for lower frequency systems such as VHF low band and amateur radio's 6 and 10 meter system installations. This is mostly due to the lack of availability and large size of a low band duplexer. Lower frequencies are also a bit more tricky to use in a duplex configuration. While reducing some of the more pricey components of the zone's hardware, this configuration requires twice the equipment and double the sites per zone. Each zone requires an isolated receive-only and transmit-only site, separated by 1/4 to 1.5 miles from one another. The system layout offers the important local repeat for in-zone local communications. A half-duplex hybrid system reduces the hardware at each zone down to inexpensive link and main band transceivers. Although the least expensive, most attractive so far, and easily expandable, it still contains a standard duplex repeater as its hub and suffers badly from a lack of local repeat. The local repeat is a significant bit of functionality, and that without it, all communications within the same zone must communicate directly without help from the infrastructure. It could mean that field units within Zone 2 might have problems communicating together, but somebody 50 miles away in Zone 5 will likely have no trouble reaching both field units. Since these half-duplex nodes are only capable of transmitting or receiving, it's only possible to forward the received traffic to the link repeater and not repeating the traffic locally. Generally, this configuration is only acceptable for low-band systems due to the improved in-zone Simplex range. This concept of a half-duplex hybrid system has always been a favorite of ours because it's basic, inexpensive, and easy to expand by simply adding more remote nodes to increase coverage. The issue with this real-time layout is the lack of local repeat function. This severely limits the system's usability for in-zone communications. Its other downside is cost and technical level of using a standard duplex repeater as the main link hub for the network. First, a brief introduction to the modular kits of equipment that will replace the complex and expensive duplex hardware with simple, inexpensive, and easy-to-install alternatives. a half-duplex bidirectional relay station we call a link node. This system contains a link band transceiver and a main band transceiver. Activity on the link band will forward over the main band, and the reverse occurs when the main band sees activity. The link node is typically used in two ways: either as a main band receive or transmit only component of a duplex system using two different sites for each task, or as a half-duplex node capable of receive and transmit when used in a single site per zone system. This link node uses the following components: main band antenna, link band transceiver, and main band transceiver. This standalone Storford repeater is used as the primary repeater in a single zone system or as the link hub repeater of a multi-zone system. Consisting of nothing more than a main band antenna, transceiver, and controller, this inexpensive piece of equipment is the key to the PEG radio system. This Storford repeater uses the following components: main band antenna, Storford repeater controller, and main band transceiver. Using this half-duplex hybrid system as our foundation, but replacing the duplex link hub with an SMC100 Storford repeater controller and transceiver changes the entire dynamics of the system, leading it to become the base of all Category 3 multi-zone PEG radio systems. The technical side of linking zones together has been eliminated along with the high cost. Each zone simply needs a single site per zone, without duplex hardware, and each zone now offers local repeat. This system is what allows a multi-zone radio network to become a viable option for prepper and prepper groups despite not having any previous radio experience. Adding more coverage is as simple as adding additional nodes and pointing the link antenna towards the main Storford repeater. All new and existing zones will offer the important local repeat functionality. Since the system contains no duplex hardware, the cost is very low and doesn't require any technical experience to install or maintain the system. The final slides of this section compares latency. Latency is the duration of time it takes from the moment a field radio transmits to the moment a final destination receiver processes the audio. Each layer of radio equipment added to a system increases its latency in a traditionally linked system. Each layer we refer to as a tier. A Storford repeater's store then forward way of operating is not considered latency but simply the way it operates. The latency in a Storford repeater system when compared to a real-time system such as a standard duplex repeater system is measured in exactly the same way. In the next few slides we'll compare a real-time multi-zone standard repeater system with a multi-zone Storford repeater system to explain the advantages and disadvantages of both systems when adding tiers to a radio network. Each destination of a signal as it works its way through the network may be a base station, vehicle radio, duplex repeater, remote node control station, or a Storford repeater, all of which will be referred to as an SPP or signal processing point. Radio waves travel at the speed of light, 186,282 miles per second. Despite this incredible speed, it may not be fast enough. When adding equipment to a system in different layers or tiers, the latency becomes greater with each tier. The flow of a Storford repeater system compared to a traditionally linked standard duplex repeater network impacts the latency of each in a very different and unexpected way. In a single-tier system, it consists of a Simplex, base, mobiles, and in-band portable radios that communicate directly. With CTCSS or DCS squelch systems enabled, you can expect between 80 to 250 milliseconds of latency. A two-tier system typically has a repeater in it. Adding a repeater can add 150 to 500 milliseconds of additional latency. A three-tier system is typically a wide area coverage system that requires remote linking stations to forward radio traffic from the field units to the repeater. This is an additional 150 to 250 milliseconds of latency. A four-tier system, although rare, is the addition of the XTR vehicle or base extender repeater systems that can add an additional 150 to 250 milliseconds of latency to the system. Referring back to one of the multi-zone duplex systems shows an example of a three-tier network. The linking repeater would be Tier 1. The local zone repeaters represent Tier 2. And the field units are Tier 3. Two field units communicating in Zone 1 experience much less latency than a Zone 1 unit communicating to any other zone. Although this is a 3-tier system, there's 2 SPPs for an in-zone signal path, and 4 SPPs in a cross-zone signal path. Rearranging the system into the appropriate tier should make it easier to understand. A message sent to a field unit in zone passes 2 SPPs. Communicating to a field unit cross-zone passes 4 SPPs. The final SPP of all real-time repeater systems is the destination field radio. Due to this real-time characteristics, the latency of each SPP must be added together for the total latency sum, because they function like a communications tunnel from one field unit to another. On a Storford repeater-based system, things work very differently. Taking another look at the basis of the multi-zone Category 3 PEG radio system, the tiers and layout is identical to the previous real-time system. The Storford link repeater is Tier 1. The half-duplex local zone nodes represent Tier 2, and the field units are Tier 3. This is where the similarities end. Latency in a Storford repeater network is consistent regardless of the location within the network. This is because the Storford repeater acts as a halfway point between all zones and all field units. As long as the message from the field units arrives at the repeater intact, it will be delivered to the field units intact. Therefore, the latency experience between zones is half of a real-time repeater network in cross-zone mode. The Storford repeater essentially becomes the source of the message once it's stored on the repeater. This has the effect of moving the message from the field unit to the Storford repeater for redistribution. The latency of the Storford repeater while in its transmit cycle is the same as its receive cycle since it's at the halfway point within the network. This allows a Storford multi-zone system to be as many as 4 tiers with acceptable latency delays. These are just a few expensive hardware items that you won't be needing if you're installing a Storford repeater system. Now that you have a sense how the Storford systems compared to traditional duplex repeater systems, we'll move on to the Choosing Your Storford Repeater System section. Let's first summarize this last section. Storford repeaters don't require a duplexer filter because the Storford repeater contains no duplex components. Storford systems don't require specialized testing equipment to adjust and configure the system. Require no high level of experience or understanding to install or operate. Eliminates the possibility of a receiver descents, adding 5 to 15% more efficiency to the system. A Storford repeater is usually less than 1/4 the cost of a standard duplex repeater system. Storford systems operate at no more than 50% duty cycle regardless of the radio traffic, allowing inexpensive transceivers to be used rather than pricey dedicated transmitter and receiver combos. A change in frequency doesn't require any retuning or adjustments for supporting equipment. Storford repeater systems offer characteristics and benefits that simply don't exist in real-time duplex or simplex systems. Testing coverage in a given area can be done by one person and is self-confirming. The characteristics of the store and forward aspect of the system allow far less equipment to be used when a multi-zone system and/or a portable XTR extender system are to be installed. Storford multi-zone systems can offer half the latency of a duplex repeater networks for systems as large as 4 tiers of equipment without long latency times, increasing the usability of a system for far less cost.